Hey guys, Dr. Brown again, and tonight we're dealing with some 6th grade least common multiple problems, or it might be greatest common factors, but anyway, we're going to deal with a few of these problems, and I'm just going to read them out of the book instead of writing them all down. Here's one. I just worked this one, so let's start with it. Determine the two numbers nearest 10,000 that are divisible by 2, 3, 4, 5, 6, and 7. Wow. Okay. Get my glasses off here. I have 20/15 vision out there, but I can't read, I can't see right in front of my face. All right. The way I approached this, my plan was, since they're wanting you to find the nearest to 10,000, I need to find the least common multiple of these numbers that's nearest to 10,000. So I just got what is the least common multiple. So I did the normal thing. It's 2, 3, 4, 5, 6, 7. So I said took 2 into it. And then, of course, I drive everything down to 1. So I end up with a 1 here in this column, so that I'm only dealing with the numbers in that column. Now you have to listen to your teachers. Some teachers let you stop here because you would have 2, 2, 3, 5. And that's where it gets confusing to me. So if I drive it all, I started to grab that 5 again. But if I just put everything over here, I don't have to worry about, well, do I grab this 7 and that 5? Do I have 5 in there twice? I don't know. So anyway, drive it all the way down to 1. But you do what your teacher is asking you. But just know, if you drive it all the way down to 1, transfer the 1 over, you just have to multiply these numbers. So in my case, the least common multiple was 2 times 2 is 4, 3 times 5 is 15, 15 times 4 is 60, bring this 7 over, 60 times 7 is 420. So my least common multiple was 420. So I took the 10,000, divided 420 into it. It went 23 times with a remainder of 340. So 10,000 plus the parentheses of my least common multiple minus the remainder, so 420 minus 340, and that difference was 80. So 10,000 plus 80 gave me 10,080. That's pretty close to 10,000. But they wanted 2 of the closest numbers. So since 420 was my least common multiple, and this was already really close, I just subtracted 420 from it, and that gave me 9660. So those, the 9660 and 10,080, would be the closest numbers divisible by 2, 3, 4, 5, 6, 7. Now you may be asking, well, is it really divisible with 2, 3, 4, 5, 6, 7? Let's challenge that. Okay, let's see. Divisible by 2, we know if it's a 0, 2, 4, 6, or 8 here. So both of these, then it is divisible by 2, so that is. We also know 8, if you add the numbers together, 8 plus 1 is 9. 9 is divisible by 3. That works. Let me check these off. 2 and 3, we got that. Well, if it's divisible with 2 and 3, it's divisible by 6. So check that one off. 5, if it's a 0 or 5 here, that's divisible. Okay, with 4, if you look at the last 2 numbers, if it's divisible by 4, well, 20 times 4 will go into that. 15 times 4 will go into 60. Hey, got that one. Let's see. 7. 7, 7, 7. All right, if I take the odd 135. Let's see. I may have forgotten a rule here. All right, 0 plus 0 plus 1 is 1. And then you're going to subtract that from the 8 plus 0. So 8 minus 1 equals 7. So that's divisible by 7. 0, 6, 9, 6, 15. Well, in this case, 9 plus 6, 15, 21. 21 is divisible by 7. So that'll go. So both of those are divisible by 7. So that takes care of that. So those two numbers are closest to 10,000. And they're all divisible by 2, 3, 4, 5, 6, and 7. Whew. I don't ever remember working a problem like that when I was in the 6th grade. So kudos to you guys. My hat's off to you. You're working some really good problems here. So keep studying. All right, let me grab my glasses again. I'm going to read another one. But basically, this one they had 3 lengths of some type of rod, and they wanted to be able to cut some number of shorter pieces out of it. And it wasn't that they had the same number of pieces in each one. It was that they didn't want any remainder in that one. Let's say they cut 5 here, maybe they cut 8 there. They just didn't want, they wanted you to figure out the length of the individual rod that you're cutting out of this thing so that there was nothing left over. So really, they want you to find the greatest common factor. As a matter of fact, when you read the problem, they actually give it away. They say, find the greatest length of rod, the greatest length of rod that can measure exactly 42 meters, 9 meters, and 84 meters. Find the number of times the rod is contained in each length. I think they could have done a better job writing that, but nevertheless, that's what they said. So, but it means this. They just want you to figure out what individual, what's this dimension right here, such that I get some number out of this that all divides into 84. This divides into 49, divides into 42, but obviously it divides into all of them. And they said the greatest length. So when they use the word greatest, they're talking greatest common factor. So what's the factors of 42? Well, 42 divided by 2 would be 21. 21 divided by 7 is 3. 3 divided by 3 is 1. Bring the 1 over. 49, let me do the same thing there. Well, 7 will go into that 7 times. 7 divided by 7 is 1. Bring the 1 over. 84. What's the greatest common factors of 84? I can put a 2 into it. So it'd be 42. 2 into that would be 21. 7 would go into that 3 times. 3 into 3, 1. Bring that over. Well, there's no 2 in this column, so the 2's are out. There's no 3 in that column, so the 3's are out. There's a 7, and a 7. So my greatest common factor is a 7. So, what does that mean? 42 divided by 7 would give me 6. I could get 6 of the 7 meters, since this was in meters. This is in meters. So I get 6, 42 meters divided by 7 meters, and meters cancel. I get 6 units out of that. 49 divided by 7 equals 7. So I can get 7 of the 7 meter rods out of that one. 84 divided by 7, 1, 7, 14, 12. I can get 12 out of that one. So 6, 6, and 12. So that would be how we could answer that one. Okay. Let me grab my glasses and we'll read another one. These were good problems. Find the least number that when divided by 8, 12, 16, and 24 have the same remainder, which was 5 in each case. 8, 12, 16, 24. 8, 12, 16, 24. 8, 12, 16, 24, and remainder was 5. So they're saying they want you to come up with some number, and it says find the least number. Least, they're always telling you either greatest or least. If they say greatest, it's the greatest common factor. If it's least, it's the least common multiple. So let's find the least common multiple. Well, let's pick a 2 here. 4 times 2 is 8. 6 times 2 is 12. 8 times 2 is 16. 12 times 2 is 24. Let's do 2 again. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. 6 times 2 is 12. Let's do 2 again. Hey. 2 divided by 2 is 1. Bring the 3 down. 2 times 2 is 4. 3 times 2 is 6. Let me do 2 one more time. You know me, I'm trying to get rid of, bring it all down to ones. Now I'll go with 3, drop the 1 down. 3 divided by 3 is 1. Bring the 1 down. 3 divided by 3 is 1. Bring the 1 over. Now my least common multiple. 2, this all together gives me 16 times 3 times 1 gives me 48. 16 times 3 times 1 is 48. Least common multiple. Okay, they wanted a remainder of 5. Well, why don't I just take the least common multiple plus 5, which would be 48 plus 5, which is what, 53? Okay, let's take 53 divided by 8. Well, my common multiple, 6 times 8 was 48. 48 from 53 is 5. What about 53 divided by 12? 12, 24, 36, 48. 4, 48. Every one of them is going to give me 48, remainder of 5. 16 into 53. Wow, 16 times 3 is 48. 48 from 53 gives me 5. 24. 24, 53. 2 times 24 is 48. That's why finding the least common multiple of 48 and adding 5 to it, we knew in each case we were going to have 5 remainder. So not so hard. The next one was a little tricky though, I thought. They had me going for a while. All right, let me get my eyes on here. Well, maybe I don't need it. Find the least number. Find the least number when divided by 12, 15, 18, 30. 12, 15, 18, 30. 12, 15, 18, 30. 12, 15, 18, 30. Okay. Find the least number. So we've got to find the least common multiple. They're telling you least. But it gives a remainder of 6, 9, 12, 24. 6, 9, 12, 24. That's my remainder. This is the numbers here. So I'm trying to divide, have some number that when I divide this into it, I get a remainder of 6. But when I divide 15 into it, I get a remainder of 9. When I divide 18 into this number, I get a remainder of 12. And when I divide 30 into it, I get a remainder of 24. Whoa, what to do? The key here was, you'll notice the difference between 12 and 15 is 3. 6 plus 3 is 9. Difference between 15 and 18 is 3. 9 plus 3 is 12. Difference between 18 and 30 is 12. 12 plus that is 24. So there's a correlation between the difference in the numbers and what you want the remainder to be. So having said that, I thought, well, in the beginning I said, let me just come up with a least common multiple and add 6 to it. Well, when I added 6 to it, it took away from this difference. So I should have subtracted that. And when I did that, the rest of it just fell in place. So let's do that. Let's find the least common multiple of these numbers and then subtract 6 from it and see what we end up with. All right, let's go with 3. 4 times 3 is 12, 5 times 3 is 15, 6 times 3 is 18, 10 times 3 is 30. All right, let's go with 2. 2 times 2 is 4, bring the 5 down. 3 times 2 is 6, 5 times 2 is 10. Let's go with 2 again. I'll get rid of that 2. That 2 divided by 2 is 1. Bring the 5 down, 3 down, 5 down. Let me go with the 3. 5, I'll get rid of the 3. Bring the 5 down. 5, 1, 1, 1, 1. Bring the 1 over. All right, what do we have here? 5 times 3 is 15. 2 times 2 is 4. 4 times 3 is 12. 12 times 15. 10. 5. 6, sorry. 1 times 2 is 2. 1 times 1 is 1. 180. All right. So least common multiple, 180. If I subtract 6 from that, 180 minus 6 gives me 174. All right, let's try 174 divided by 12. Okay, 1 times 12 is 12, 54. 12 times 4, 36, 48. So 4, 48. 48 from 54, voila, 6. Now hopefully when I do 15, so 174 divided by 15, 1 is 15, gives me 24, and then 1 time again, so that's 15. So guess what? Well, that's 9. That's what I wanted. If you keep going, you'll get a 12. Well, let's just keep going. 174 divided by 18. 18, oh, let's see, 5 times 8, well, 10 would be 180, so let's go 9. 9 times 8, 72, 7, 9 is 16, so that's 2, that's 12. Hey, that's what we wanted. And let's do one more. So we would have 174 divided by 30, this guy here. 5 times 30 is 150, and that leaves me 24, which is the remainder that I wanted. Okay, and it took me a little while to get this, I'll just be honest with you. I wanted to add the 6 instead of subtracting it away. Okay. What else do we have here? Let's see. All right, the greatest common factor of two numbers is 23. So it's saying the greatest common factor of two numbers is 23. Okay, and their least common multiple is 1449. Okay, and it says if one of the numbers is 161, so 161, I'm just going to write that over here for the moment. The greatest common factor we know is A times B divided by least common multiple. Okay, so we know that. Also, if I were to take and multiply both sides of that times the least common multiple, well, least common multiple divided by least common multiple is 1, and 1 times A times B is A times B. So now I have the least common multiple times the greatest common factor equals A times B. Well, if I said A was the 161, so A equals 161. And I'm trying to solve for B, so B equals what? That's what they're wanting to know. What's the other number? So if I divide both sides by A divided by A is 1. 1 times B equals B. So now I have least common multiple times greatest common factor divided by A. Well, I know all of those, so just fill in the blanks. So least common multiple, 1,449 times, so I usually just put the parentheses around it. Anyway, you'll start doing that later. Times 23 divided by 161. I did this earlier for the sake of time. That's 207. So B equals 207. So that would be our answer. So you can take that formulation, and because we knew that the greatest common factor equals A times B, my two numbers, divided by least common multiple. And then you just work it around like this to solve for what it is you need to know. Okay? All right. This next one, I don't know if you can hear the cat squalling outside. We always have some critter making noise. Usually it's the chickens across the road crowing. All right. 4 bells ring simultaneously at intervals of 3, 4, 5, and 6 seconds. 3, 4, 5, and 6. 3, 4, 5, and 6 seconds. Okay, they want to know at what interval or what time do they all ring at the same time? Let's for just a moment think that it's just 2 for the moment. I won't forget my 5 and 6. Let's assume it's just 2 bells. Okay, we have a timeline here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, these are seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? We have, and they all ring at 0. Bing, boom. Okay, they ring. Well, this one's 3 seconds later. We'll let this one be a circle and this one be a square. So at 3 seconds, that one rings. So at multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay, that one would ring. Every 4 seconds then, so this one rang at 0. At 4 seconds, it rings. At 8 seconds, it rings. 1, 2, 3, 4 seconds later, it rings. So if you only had the 3 and the 4, they both would ring at the same time every 12 seconds. So that's what they're asking. They want you, what did this mean? I just found the least common multiple of a 3 and a 4. It's 12. Well, how do we know that? So let's do a 3. 3 divided by 3 is 1. Bring down to 4. 2, bring the 1 down. 2 times 2 is 4, another 2. 2 divided by 2 is 1, bring the 1 over. 2 times 2 is 4, 3 times 4 is 12. So I know the least common multiple of 3 and 4 is 12. But they're asking, they have 4 bells, and one of them rings every 5 seconds, one rings every 6. They want to know, when do they all ring at the same time? So we need to find the least common multiple of 3, 4, 5, and 6. So that's the question. Okay, let me get rid of the 3. 3 divided by 3 is 1. Bring the 4 down, the 5 down. 2 times 3 is 6. I'll get a 2 out of that. So 2 times 2 is 4. Bring the 5 down. 2 divided by 2 is 1. All right, let me do a 2 again. Get rid of that 2. Bring the 5 down, 1 down, 5. 1, 1, 1, 1. Bring a 1 over. All right, 5 times 3 is 15. 15 times 4 is 60. So my least common multiple equals 60. So the answer, when would they ring again? It's at 60 seconds. 5 times 3 is 15 times 4. So every 60 seconds you would get all of these to chime. All right. Let's do one last one. When a seller counts eggs by 2, he counts them by 2s, 3s, 4s, and 5s. They have remainders of 1, 2, 3, and 4 respectively. How many eggs does she have? So she has a group of eggs, and sometimes she's going 2, 4, 6, 8, 10, 12. And when she does that, she has a leftover of 1. So she's counting in 2, 3, 4, and 5. 2, 3, 4, and 5. And the remainder is 1, 2, 3, and 4. Let me make certain that's right. 1, 2, 3, and 4, yes. So the question is, how many eggs does this person have? Well, let's find the least, and same as before. The difference between this to this is 1, just like that. Difference is 1, just like this. Difference is 1. So it may be, if we can find the least common multiple and subtract 1 from it, that may satisfy this for all of it. So let's find that number. Well, let's divide by 2. 1 times 2 is 2. Bring the 3 down. 2 times 2 is 4. Bring the 5 down. Let's get rid of the 2 again. Bring the 3 down. 1 times 2 is 2. Bring the 5 down. All right, let's get rid of the 3. 1 times 3 is 3. Bring the 1 down. Bring the 5 down. Let's get rid of the 5. Bring the 1 over. All right. 5 times 3 is 15. 15 times 4 is 60. So the least common multiple is 60. All right, when she counted by 2s, they wanted to have a remainder of 1. So I'm going to subtract 1 from that and say it's 59. So let's say there's 59 and divide it by 2. Well, that'll go into 2. 2 times 2 is 4. Subtract 4 from 5 leaves me 1. Bring the 9 down, it's 19. Oh, 9 times 2 is 18. 19 minus 18 is 1. Whoa. Oh, let's not get too excited yet. Now then, what happens when we divide it by 3? Well, 1 times 3 is 3. That leaves me 29. 9 times 3 is 27. Hey, awesome. 29 minus 27 is 2. So when they counted 3 and 3s, 3, 6, 9, 12, they had 2 left over. All right, 59 divided by 4. I go into it 1 time. 1 times 4 is 4. That left me 19. 4 times 4 is 16. That left me 3, which is what I wanted. All right, 59 and 5. 1 times 5 is 5. That's 0. Bring down to 9. 1 times 5 is 5. That leaves me 4, which is what I wanted. Okay. These were some excellent problems, I thought. These were some pretty good head scratchers for 6th graders for sure. Actually, I showed these to a lot of high school students who couldn't work them either. So anyway, you guys keep doing what you're doing and learn these. Hopefully these will help you some to understand the logic behind why we're doing what we're doing here. So, all right, why are we doing all this? Okay, because together we're going to build a better tomorrow, and we're going to do that. How? Through math. Okay, that's all for now. Study, 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 and we'll talk to you next time. Thanks. Bye.